Electric fuse. A fuse is a safety device which prevents damages to electrical circuits and possible wires. A fuse consists essentially of a metal strip or wire that melts at a lower temperature than the wire and other components in the rest of the circuit. The fuse is connected in series with a source of electric power. There is a maximum limit on the current which can safely flow through the circuit. When the current flowing in the circuit becomes too strong, it heats the fuse so that it melts, breaking the circuit. Reasons for excessive current in circuit. Direct touching of wires. This is caused if wires in the circuit are in direct contact. This happens if insulation on the wires has come off due to wear and tear. This may cause a short circuit. Connection of many devices to a single socket. If many devices are connected to a single socket, overloading may occur. Note: miniature circuit breakers are used in place of fuses. These are switches which automatically turn off when current in a circuit exceeds the safe limit and turn them on and the circuit is on once again. Magnetic effects of electric current. Take the discarded tray from inside a discarded matchbox. Put a compass needle inside it. Wrap an electric wire a few times around the cardboard tray. Now connect the free edges of the wire to an electric cell through a switch. Observe the direction of deflection of compass needle. Bring a bar magnet near the compass needle. Now switch on the circuit. Observe the deflection of compass needle. Now switch off the circuit. Observe the deflection of compass needle. The compass needle is a tiny magnet which points in north-south direction. When we bring a magnet close to it, the needle gets deflected. The compass needle also gets deflected when current flows through the wire. When electric current passes through a wire starts behaving like a magnet. This is a magnetic effects of electric current. Electromagnet. An electromagnet is a type of magnet whose magnetic field is produced by the flow of electric current. The magnetic field disappears when the current ceases. Electromagnets usually consist of a large number of closely spaced turns of wire that create the magnetic field. Electromagnets are very widely used as components of other electrical devices such as relays, scientific instruments, MRI machines, motors, generators, loudspeakers, hard disks, and magnetic separation equipment, as well as being employed as industrial lifting electromagnets for picking up and moving heavy iron objects like scrap iron. Electric bell. It consists of a coil of wire wound on an iron piece. The coil acts as an electromagnet. An iron strip with a hammer at one end is kept close to the electromagnet. There is a contact screw near the iron strip. When the iron strip is in contact with the screw, the current flows through the coil, which becomes an electromagnet. It then pulls the iron strip. In this process, the hammer at the end of the strip strikes the gong of the bell to produce a sound. However, when the electromagnet pulls the iron strip, it also breaks the circuit. The current through the coil stops flowing.